welcome to this particular module. Here what I want to show it to you is, in the previous modules we have seen a process flow for fabricating 3 different kind of chips. If I want to say 2 chips and 1 sensor, that will make more sense, because we have fabricated a piezoresistive micro cantilever, and then we have also seen interdigitated electrodes, and then we have seen a flexible sensor with electrical and mechanical modality that can understand or that can measure the electrical and mechanical modalities. And then we have seen a chip which is integrated with electrical, mechanical and thermal sensors to understand the electro-thermomechanical properties of the tissues. These tissues we are talking about is from the oral cancer or the breast cancer. Now, what we are interested is, can we design a system that can understand the change in the tissue property as cancer progresses. So, let us see now whatever we have learned, how the thing looks like, right, and that will give you a better idea of the dimensions and the chips that we are talking about. So, first let us see the slide and then I will show you the chip. Okay. If you see the slide, this is the chip that we are talking about, and if you remember, this chip that we discussed has a heater and then there is an insulator, right, heater and then insulator, then interdigitated electrodes, over that you have piezoresistive sensor, over that insulator, over that you have gold electrodes with a SU8 pillar, and SU8 pillar we are coating with gold. Then we have a diaphragm on the back side of the chip, because when we want to press the piezoresistive sensor, the silicon should bend, and if you have thin diaphragm it will bend depending on the tissue stiffness, right, and this is how the chip looks like, but it is difficult to see exactly what are the things within the chip. So, let me now show it to you how exactly the chip looks like. If you see my hand, then you will understand. This is a chip that I am holding in my hand. If you see, these are the chips 1, 2, 3, 4, 5, 6, okay, and the one that I am showing it to you right over here, right, which is the center of the this chips. This chip, all the chip in fact consist of the dot in the center, the dot in the center of the chip consists of all 3 sensors together, all right. So, it is really tiny. If you see, it is really tiny, and that is why we say it is a micro electromechanical systems based sensors, all right. So, this is a MEMS based biochip, and as you can see, the center of the chip there is a gold circle, right, that itself is a gold pad, and over that gold pad there are SU8 pillars, which unfortunately you cannot see through the camera, but we need to have a high magnified view of that, and that is why we are showing it to you, or particularly in this slide I am showing it to you the SEM image of the chip, right, it is very clear. So, this is how the chip looks like. This chip we will place inside the 3D printed casing, and then we will perform the experiments, right. So, this is one thing. Now, if you go back to the slide and you see the second one, which is the piezoresistive sensor. Now, you understand that the piezoresistive micro cantilever, it was used to understand the stiffness of the tissue, stiffness, how stiff the tissue is, whether tissue is from benign region or it is from cancer region, right, benign region or cancer region, what is the tissue stiffness. This if you want to understand, then we can fabricate a piezoresistive micro cantilever, and as you can see here, we are indenting the tissue, right, with the help of a MP285 micro manipulator, and when you indent the tissue, what will happen, depending on the stiffness of the tissue, the cantilever will bend. This is the cantilever that we are talking about, right, and this is a chip, this is a chip. Okay. So, I will show it to you why I am drawing the circle around the cantilever and around the chip. This is the chip, right, and this guy is a cantilever. Of course, the complete chip we are need to use, because this is connected to the contact of the cantilever, this is connected to the contact of the cantilever, and this is a cantilever beam, and there is a SU8 tip at the edge of the cantilever beam. Okay. So, now if you see, if I want to show it to you how this chip looks like, let us see in my hand. If you focus on my hand, you will see, if you can zoom in please again, if you can zoom in, yeah, thank you. So, whatever maximum you can zoom in, still you cannot see the micro cantilever chip, and that is the beauty of the microfabrication. This chip is really tiny. I am showing you these two chips right over here, the top of the this particular disk, and the chip that you can see, right, is just without, you cannot see the cantilever. The cantilever is about 130 microns, you cannot see it, right. Human hair is from 80 to 100 microns. The chip consists of the micro cantilever, which is 130 micron. You cannot see with your naked eye, or it will be very difficult to see with your naked eye, but what you can see here is the chip, right, without micro cantilever, right. Of course, there is a micro cantilever, but you cannot see the micro cantilever, that is what I mean without micro cantilever. So, the chip has a piezoresistive micro cantilever, but you cannot see the cantilever, but you can see the chip, right. So, this is how the chip looks like. It is extremely tiny, right, extremely tiny. So, very difficult to handle. Compared to this, it is very difficult to handle the chips which is having the piezoresistive micro cantilever, right. Now, let us see the third version. So, if you come back to the slide, what I will show it to you, I will show you the third version, that is our flexible sensor, right. The flexible sensor, and it consisted of what, or it was integrated with what? It was integrated with electrical sensor, that is your gold pad and SU 8 pillars which were conductive, and it was having the piezoresistive sensor. Piezoresistive sensor consists of P dot PSS. P dot PSS is what? It is a conducting polymer, right. It is a conducting polymer, and it shows the piezoresistive property. That means, whenever we press the material, then there will be change in the resistance of the material, right. So, that is the piezoresistivity of the material. So, we have used the P dot PS as a piezoresistor, we have patterned it, you can see a single piezoresistor here. Then we deposited insulating material, we opened the contact area, then we had gold pad you can see right over here, and finally, after gold pad we were having SU 8 pillars, right, and we made SU 8 pillars conductive, right. The chip looks like the one here, right, and in when you make it up, when you etch it or when you strip it from the base layer, that is your oxidized silicon wafer, it is a flexible material, as I have shown you, as you can see from the optical image, right, and it is a flexible material, you can see it right over here. In fact, you have seen in the videos as well. Now, my point is, how does it look like if I want to make this on the oxidized silicon substrate? Again, you understand that everything that I am showing it to you, you should wear gloves and it should be a clean room environment, but since this is the class, I am trying to show it to you without gloves, but this is not a correct technique, okay. This is not a correct technique, but just to show it to you. So, these are the sensors, these are the chips in which at the center of the chip, at the center of each chip, at the center of each chip, right, a center of 1, 2, 3 and 4, right, at the center there is piezoresistors and there is the gold pad, and over gold pad what is that? Over gold pad we have SU 8 pillars, and that SU 8, those SU 8 pillars, in fact, because we have 8 of those SU 8 pillars are conductive. So, this chip consists of 8 piezoresistors and 8 gold pads. So, you can say piezoresistors for mechanical property of tissue, gold pad for electrical property of tissue, and as you can see, all the things that is star thing shape you can see are the contacts to the piezoresistor or to the gold pad. The sensor is in the center of this chip, is in the center of this chip. So, it is again extremely tiny, that is why we say this is a micro sensor or MEMS based device, right, MEMS based sensor, all right. So, this is the one that I wanted to show it to you, so that you have idea how it looks like. Of course, the one that I have shown on this particular oxidized silicon substrate, it is on oxidized silicon substrate, it is not on PDMS. If it was on PDMS, we can also make a flexible material now, but the results that we have obtained is using the flexible sensor, okay. So, now I hope that you understand how the sensor looks like when we actually fabricate it, right. So, it is not only to understand how the process flow looks like, but also to understand how the final device looks like. Now, what you will do with this device? You will understand the change in the output of this device. Now, in case of the first chip, that as thermal changes, we can see the change in temperature, then and also change in resistance, and there is a change in resistance again because there is a piezoresistive material. In second one cantilever, it was a piezoresistive cantilever, we will see change in the resistance. In the third one, where it was a piezoresistor and gold pad, we will see change in resistance in both the cases, whether it is mechanical or electrical. Since mechanical there is a piezoresistor, it will show change in resistance, and electrical of course depending on the resistance of the tissue, you can see change in current. That current will corresponds to the change in the tissue resistance. Thus, we have to understand the change in resistance, but in most of the cases you will see that if the piezoresistor is not so sensitive, you have to work on the electronic module of the system, and then the electronic conditioning circuit becomes very important part when you want to amplify the signal coming out of the sensor or a transducer, right. So, we will see electronic conditioning circuit sometime later as a part of this particular lecture, and yeah, the idea of this particular module what was to just show it to you what kind of sensors that you are right now learning looks like when you actually fabricate it. Alright. So, this is the end of this particular module. I will see you in the next module and we will talk about very interesting problem, and that is the screening of cancer patients. So, if someone comes, or if the doctor comes to a let us say a small village, right, or a small district, let us say primary healthcare centers, then how the screening is done, and can we design an alternative system or system based on electronics such that the screening will become easier and more powerful, right. So, we will talk about that in detail in the next module, and till then you take care. I will see you in the next class.